Dear friends, fellows, and colleagues, our today's topic is accident investigation with practical workplace scenarios and how to control or manage risks at site. I'm your host, Javed, and you're watching Safety First. As usual, if you are new on this channel, kindly subscribe the channel. And if you find the video informative, then like and share. Let us discuss the procedure, how to make accident investigation. But prior to jump on the main topic, let us understand the basic terms. The definition of these terms are very, very important to know what is accident, what is incident, and what is near miss, because these words will be in repetition during the training presentation. So, what is accident? Accident is an undesired, unexpected event that results in personal injury or property damage. Incident. An incident is an unplanned and undesired event too that adversely affects completion of a task. There might be an injury and there may be not. What is near miss? Near misses describe incidents where no property was damaged and no personal injury sustained, but where, given a slight shift in time or position, damage and injury easily could have occurred. If I will simplify these terms, in the accident, there is a damage, there is an injury. In the incident, there might be an injury, might be damage, maybe not. In the near miss, there is no personal injury, there is no damage at all. But there was the possibility of damage or injury. Now, let us see, when do we conduct an investigation? All incidents, whether a near miss or an actual injury related event, should be investigated. Near miss reporting and investigation allow you to identify and control hazards before they cause a more serious incident. Accident or incident investigations are a tool for uncovering hazards that either were missed earlier or have managed to slip out of the controls planned for them. It is useful only when done with the aim of discovering every contributing factor to the accident or incident to foolproof the condition and or activity and prevent future occurrences. The objective of the accident investigation is to identify root causes. The question is, who should investigate the accident? Management, employees, safety representative, or a safety committee? Let us discuss one by one. The usual investigator for all incidents is the supervisor in charge of the involved area and our activity. The supervisory staff or the management must be the part of accident investigation. As long as the employees are concerned, accident investigations represent a good way to involve employees in safety and health. Employee involvement will not only give you additional expertise and insight, but in the eyes of the workers will lend credibility to the results. Employee involvement also benefits the involved employees by educating them on potential hazards, and the experience usually makes them believers in the importance of safety, thus strengthening the safety culture of the organization. What will be the role of safety representative? The safety department or the person in charge of safety and health should participate in the investigation or review the investigate findings and recommendation. What will be the role of safety committee? Many companies use a team or a subcommittee or the joint employee management committee to investigate incidents involving serious injury or extensive property damage. In short, management, employees, safety representative or safety department, and safety committee all will be involved in an accident investigation process. Numerous employees are affected by workplace injuries or damaged property. So, all the accidents need to be investigated, and all the findings and lessons learned must be communicated to the workforce to avoid reoccurrences of the similar nature of accidents in the workplace. Do you think the training is required for accident investigators? Yes, of course. Investigators need basic training. No one should investigate incidents without appropriate accident investigation training. The aim and objective of the investigation is to recognize root cause. A good investigation is likely to reveal several contributing factors, and it probably will recommend several preventive actions. For investigations, there might be the requirement of technical skills as well. Understanding of tasks being performed at the time of the accident, understanding of environmental influences on the time of accident. Investigator answers the six basic questions: who, what, when, where, why, and how. Not everyone in an organization is prepared to conduct investigation. Training is required for investigators to know how they will carry out investigations that must be productive and beneficial. They have to find out the root causes, and that's why they must be specialized in the investigation process. Dear friends and fellows, you are watching Safety First, and today's topic is accident investigation with the real workplace scenarios, and based on the investigations, how to control the risks. Now, let us discuss the investigation traps, mainly three in number. Number one, blame without proof, policies that miss the mark. And number three, lack of accountability. Let us understand what is the meaning of blame without proof. The error made by the employee may not be the most important contributing cause. The employee who has not followed prescribed procedure may have been encouraged directly or indirectly by a supervisor or production quotas to cut corners or to make shortcuts. Policies that miss the mark. The second trap during the investigation. The prescribed procedure may not be practical or even safe. Sometimes, where elaborate and difficult procedures are required, engineering redesign might be a better answer. Number three, lack of accountability. Supervisors and others who investigate incidents should be held accountable for describing causes carefully and clearly. When reviewing accident investigation reports, the safety professional should be on the lookout for catchphrases. For example, employee didn't plan job properly. While such a statement may suggest an underlying problems with this worker, it is not conducive to identifying all possible causes, preventions, and controls. Certainly, it is too late to plan a job when the employee is about to do it. Further, it is unlikely that safe work will always result when each employee is expected to plan procedures alone. In short, investigations should result in meaningful results. But if the investigators are untrained, they might be trapped, will not be able to uncover the root causes. That is the basic motive, objective, and aim of an accident investigation. The primary purpose of accident investigation is to prevent future occurrences. For example, the job hazard analysis should be revised and employees retrained to the extent. that it fully reflects the recommendations made by an incident report. Implications from the root causes of the accident need to be analyzed for their impact on all other operations and procedures. Recommended preventive actions should make it very difficult, if not impossible, for the incident to recur. We will discuss how are the results of investigation incorporated into a meaningful corrective action. During the investigation, the interview is the basic fundamental part of investigation. Take notes, ask open ended questions. What did you see? What happened? Do not make suggestions. If the person is stumbling over a word or concept, don't help them out. Use closed ended questions later to gain more detail. After the person has provided their explanation, these type of questions can be used to clarify: where were you standing? What time did it happen? Don't ask leading questions. For example, the bad question is, why was the forklift operator driving recklessly? The good question is, how was the forklift operator driving? So, an investigator must understand the concept of questioning, good or bad. If the witness begins to offer reasons, excuses, or explanations, politely decline that knowledge and remind them to stick with the facts. Then summarize what you have been told. Correct misunderstandings of the events between you and the witness. Then ask the witness for recommendations to prevent reoccurrence. These people will often have the best solutions to the problem. After the interview, you need to record the facts. Interview witnesses as soon as possible. If possible, document the accident scene before changes are made. Take photos, draw scaled sketches, and record measurements. Then collect supportive documents. Keep all notes and remarks in a bound notebook or three-ring binder. Record pre-accident conditions, accident sequence, and post-accident conditions. Document victim, location, witnesses, machinery, energy sources, and other contributing factors. Even the most insignificant detail may be useful. Remember, information recorded will become part of the permanent record of the occurrence and should be as accurate as possible. Now, we will discuss how to make investigation report and what are the possible items or elements that should be the part of investigation report. An accident investigation is not complete until a report is prepared and submitted. You have to highlight background information: where and when the accident occurred, who and what were involved, operating personnel, and other witnesses. Then you will describe the account of accident, what happened, sequence of events, extent of damage, accident type, and agency or source of accident. Lastly, you will put recommendations to prevent reoccurrences for immediate and long-range action remedy, basic causes, indirect causes, and direct causes. Dear friends and fellows, let us conduct accident investigation exercise. We will create a scenario. We will discuss the scenario. Then, accordingly, we'll complete the investigation report and we will identify the unsafe acts or conditions that cause the injury or the damage. Accident number one. You have to listen and understand carefully. A laborer was killed when a gasoline storage tank he was cutting with a portable power saw exploded. The workers' company was involved in installing removing and junking gasoline pumps and underground tanks. Although he had experience working with the saw and scrap materials, the worker didn't adequately pulp the tank and test for vapors before beginning to cut. The 18 by 6 foot 3,000-gallon tank had been used recently for underground storage at a service station. At the time of explosion, the mechanic was cutting on the tank with a gasoline-powered portable saw equipped with an abrasive epoxy disc for cutting metal. The explosion propelled the worker 10 to 15 feet from the tank into another tank. So this is accident number one, or the result of accident. Let us discuss accident number two. Two employees were painting the exterior of the three-story building when one of the two outriggers on their two-point suspension scaffold failed. One painter safely climbed back onto the roof while the other fell approximately 35 feet to his death. The outriggers were inadequately counterweighted with three 5-gallon buckets containing sand and were not secured to a structurally sound portion of the building. Neither painter was wearing an approved safety belt and lanyard attached to an independent lifeline. This is scenario number two. You can easily understand a person fall from the height of 35 feet. The condition of the painter and the condition of scaffold is already in your notice. So, based on these scenarios, we will make an investigation report. Accident number three. The employee was attempting to correct an electrical problem involving two non-operational lamps. He proceeded to the area where he thought the problem was. He had not shut off the power at the circuit breaker panel, nor had he tested the wires to see if they were live. He was electrocuted when he grabbed the two live wires with his left hand and then fell from the ladder. Dear friends and fellows, scenario number one, explosion. Scenario number two, fall from height. And scenario number three, that is electrocution. Now, we will discuss root cause analysis. Root cause analysis seeks to identify the origin of a problem. It uses a specific set of steps with associated tools to find the primary cause of the problem so that you can determine what happened, determine why it happened, figure out what to do to ensure it will not happen again. Ultimately, this is also the purpose and the objective of accident investigation too. There are three main root causes: physical causes, human causes, and organizational causes. Physical causes are the work factor. Tangible material items failed in some way. For example, a car's brake stopped working. This is the example of physical causes or work factors. Let us discuss what are the human causes or unsafe acts. People did something wrong or didn't doing something that was needed. Human causes typically lead to physical causes. For example, no one filled the brake fluid, which led to the brakes failing. This is an unsafe act or human cause. Let us know what are organizational causes or unsafe conditions. A system, process, or policy that people use to make decisions or do their work is faulty. For example, no one person was responsible for vehicle maintenance, and everyone assumed someone else checked the brake fluid level in the service trucks, and this was the cause of accident. During the process of root cause analysis, you have to define the problem. What is the negative result? What are the specific symptoms? you have to collect data. How long has the problem existed? What is the impact of the problem? Then you have to identify possible causal factors. What sequence of events leads to the problem? What conditions allow the problem to occur? Then you have to identify the root causes. Ask why. What is the real reason the problem occurred? And lastly, you have to recommend and implement solutions. What can you do to prevent the problem from happening again? How will the solution be implemented? Root cause is different from accident reporting. In some cases, employers or those conducting investigations may look to report what happened, but not focus on prevention of a reoccurrence. Team leaders or investigators must ensure the remedial action and the implementation process. Otherwise, the investigation report shall not be considered as a complete or comprehensive report. To find out the root causes, five whys concept is important and basic. Remember the rule of five whys by repeatedly asking the question why. Five is a good rule of thumb. You can peel away the layers of symptoms which can lead to the root cause of a problem. Very often, the reason for a problem will lead you to another question. Although this technique is called five whys, you may find that you will need to ask the question fewer or more times than five before you find the issue related to a problem. The root cause technique could be discussed in small groups or by the larger group as a whole. The purpose is to get participants to look past initial findings and get to the single action that, if prevented, would not result in injury. Now, we will discuss five why scenario. The scenario is a worker was busy in painting and he was standing on a ladder. He fall and get injured. There shall be five questions started with why and their possible answers. Your concentration is important now to understand the concept of five whys. Why number one? Why did the employee fall from the ladder? The employee reached beyond the ladder's balance point and the ladder tipped over. This is the answer. Question number two, second why. Why did the employee reach out and not reposition the ladder? Because if he will shift the ladder, he may not fall. The answer is because there were several pallets of material in the way and he couldn't move the ladder into the correct position. Number third question and third why. Why were pallets stored in an area being painted? The materials being stored on the pallets were not scheduled to installation for several weeks, but due to weather conditions, the material had been moved inside. This was the answer. Question number four. Fourth why. Why were the pallets not moved so the painter could appropriately access the work area? The controlling and creating contractor was not contacted and the painting work was not scheduled. The hazard was not identified during the JHA, job hazard analysis, and the employee proceeded with his assigned tasks in a manner he thought was expected. Question number five, that starts with why. Why was the JHA not completed? Supervisor was not appropriately trained and didn't conduct a JHA as required by site and employer requirement. So what is the root cause? After five whys, five questions, you are easily able to understand the root cause. The root cause was that the supervisor who assigned the task was not trained to complete JHA and he allowed the worker with incomplete or unsafe procedures that lead to an accident. What will be the root cause solution? Ensure all supervision staff are appropriately trained to conduct job hazard analysis and action plans communicated to affected personnel. We were able to know that job hazard analysis was missing. Let us understand what is the purpose of JHA, job hazard analysis. A means of systematically identifying workplace hazards as they occur is needed so that hazards can be eliminated before accidents occur. The greater the number of ways that problems are brought to management's attention, the less likely is it that an accident will occur when one of the protective systems fail. JHA are known by many names like AHA, like JSA, like JHA, but whatever the name is, the information must be understood by the workers and communicated by the supervising staff while they are going to deploy a worker on a particular task or activity. Dear friends and fellows, job hazard analysis is also a five-step process. Step one, watch the work being done. What are some effective methods to watch the work being done? Is it important to involve the employee performing the task? Step two, break the job down into steps. Step number three, describe the hazards in each step of the task. The primary purpose of JHA is to make the job safer. The information gathered in this step will be valuable in helping to eliminate and or reduce hazards associated with the job and improve the system weaknesses that produce them. Step number four, control measures. And step number five, documentation. The fix the system culture is one that makes every effort to address the hazards in the workplace by first identifying the hazardous conditions or practices, analyzing the hazard to determine the root cause, and then eliminate those hazards by correcting the deficiencies in the system. Could include supervisor training, improved accountability system, and establishment of standards of performance at all levels. The question is how to identify the type of hazard. There are different types of hazards. In mechanical, caught in, caught between, faults, electrical, temperature, environmental hazards, flammability, fire, confined space. In ergonomic, high frequency, high duration, high force, posture, point of operation, mechanical pressure, vibration, or environmental exposure, etc. Other than the normal hazards, there are some special hazards too, like explosives, electrical contact, or chemical reactions. In explosives, explosions result in large amount of gas, heat, noise, light, and overpressure. In electrical hazards, inadequate insulation, broken electrical lines or equipment, lightning strike or static discharge, etc. In chemical reactions can be violent, can cause explosions, dispersion of material, and emission of heat. Special hazards, while not always routine, must be understood by investigators and documented. Now, we will discuss the hierarchy of controls, engineering controls, administrative controls, and personal protective equipment. Always remember, engineering control is the most desirable as it provides the highest level of protection for workers, and PPE, personal protective equipment, is the last line of defense. Let us understand what are engineering controls. The first, and bus strategy to control the hazard at its source. Engineering controls do this, unlike other controls that generally focus on the employee exposed to the hazard. The basic concept behind engineering controls is that, to the extent feasible, the work environment and the job itself should be designed to eliminate hazards or reduce exposure to the hazards. Engineering controls can be simple in some cases. They are based on the following principle. If feasible, design the facility, equipment, or process to remove the hazard, or substitute something that is not hazardous. If removal is not feasible, enclose the hazard to prevent exposure in normal operations. Where complete exposure is not feasible, establish barriers or local ventilation to reduce exposure to the hazard in normal operations. The examples of engineering controls might be handrails, sloping, or lockout, tagout. Number two, administrative controls, work practices. While safe work practices can be considered forms of administrative controls, uses the term administrative controls to mean other measures aimed at reducing employee exposure to the hazards. These measures include additional relief workers, exercise breaks, and rotation of workers. These types of controls are normally used in conjunction with other controls that more directly prevent or control exposure to the hazard. Unlike engineering controls, administrative and PPE control don't remove the hazard from the environment. It must be understood by all that administrative controls and the personal protective equipment seek to limit the effect of hazard has on the workers but doesn't eliminate it. In the hierarchy of control, let us discuss the importance of personal protective equipment. When exposure to hazards cannot be engineered completely out of normal operations or maintenance work, and when safe work practices and management controls cannot provide sufficient additional protection from exposure, personal protective clothing and or equipment may be required. A supplementary method of control is the use of protective clothing or equipment. This is collectively called personal protective equipment or PPE. PPE may also be appropriate for controlling hazards while engineering and work practice controls are being installed to avoid the accidents, to avoid drastic and catastrophic accidents and incidents in the workplaces. It's important to report and investigate every near miss. What is near miss? An unplanned event that didn't result in injury, illness, or damage, but had the potential to do so. Only a fortunate break in the chain of events prevented an injury, fatality, or damage. Although human error is commonly an initiating event, a faulty process or system invariably permits or compounds the harm and should be the focus of improvement. It will be appreciable that the workers will report near miss incidents. But workers and supervisors tend to not report near miss incidents if they believe it will have a negative outcome for them. So it depends on the culture of the company. What are the benefits of near miss reporting? Near miss is a zero cost learning tool. A near miss reporting system includes both mandatory for incidents with high loss potential and voluntary, non punitive reporting by witnesses. The key to any near miss report is the lesson learned. Near miss reporters are in a position to describe what they observed about genesis of the event and the factors that prevented loss from occurring. The root cause analysis should be used to identify the defect in the system that resulted in the error and factors that may help eliminate a reoccurrence. Near misses are smaller in scale, relatively simpler to analyze and easier to resolve. The importance of near miss reporting as a means of preventing a reoccurrence injuries or accidents. The incident. To understand the incident accident pyramid, have a look. There are 600 incidents with no injury or damage, means near misses. 600 close calls are warnings that someone should take action against unsafe acts, conditions, or human behaviors. But after a huge number of warnings and close calls, no one was entrusted to identify and rectify the cause. Ultimately, there is a fatality, and after the fatality, everyone is in deep trouble, but it is useless because the damage is already done. Dear friends and fellows, let us discuss why safety programs fail. Because safety is a priority, not a value. Because safety is not managed in the same manner as production, quality, and cost issues. And because safety is not driven through continuous improvement. Try to understand very clearly safety is not a one time event. Safety functions should be driven throughout the organization every day and all the days. Dear friends and fellows, do you know the risk management benefits? Reduction in material and property damage, effective project accomplishment, and reduction in serious injuries and fatalities. Remember, good risk management practice can help owners or the employers to better realize the value of an effective safety program. And that's it. Training session is over now. If you have any question, please ask in the comment section down below. Thanks for watching. Don't forget to like and share the video. Hope to see you soon with a new HSC tutorial. Till then, take care, good luck, and Allah Hafiz.